Anytime you have a function, all you got to do to find its inverse is simply switch x and y. So I'll put just a simple little function up here. I'll call this function g of x, and let's say it contains the points 4, 1, 2, negative 3, 6, 5, and negative 8, 1. Okay?
Oh my gosh.
So this function only contains 4 points. And those 4 points, it is a function because none of my x values repeat.
Yeah.
Remember, if x repeats itself, that means it's not a function. So the way you notate an inverse is like this. You just put a little -1 on the function name, and that means inverse. So the inverse is calculated or found by simply switching x with y. So if I switch x with y, then I'm going to have 1, 4, negative 3, 2. Negative 3, positive 2. 5, 6.
There's going to be a catch in this.
5, 6, and 1, negative 8. Okay, so now when you write the inverse by switching all the x's and the y's, then you have to check again and see if it's still a function. Do any of the x's repeat? Yes. This one and this one both have a 1, so that means the inverse is not a function. Okay, the inverse is not a function. Okay, sometimes it is, sometimes it's not.
That'd be the weirdest looking line.
Okay, is everybody okay with inverse? You just switch x and y. All right, so yeah, it's not a line, it's just 4 points. All right, so let's say you have a line. This is example 2. And let's say we have y is equal to 5x minus 2.
So you're going to get...
So I want to find the inverse. So to find the inverse, I need to do what? Switch what two things? Switch x and y. So if I switch x and y, I get something that looks like this, right?
Yeah.
And then I want to solve it for y. Get the y by itself. So how can I get the y by itself?
Switch it back.
Okay? I'm not going to switch the x and the y back. I'm still going to solve it for y.
Subtract by 5y.
Just add 2.
Add 2,
Add
okay.
2 over.
Add 2 over.
Divide by 5.
Divide by 5, and y comes out to be x plus 2 over 5, or that would be the same thing as 1/5 x plus 2/5. So I started out with a diagonal line, and when I found the inverse, I still have a diagonal line. So is the inverse a function?
I don't know.
Well, do diagonal lines pass the vertical line test?
Yes.
Yes, they do. So your original function, your original function was a diagonal line. Your inverse is a diagonal line. A diagonal line will always pass the vertical line test, so they are both functions. All right? So, and this is a good place where function notation actually comes in kind of handy, because if I were to just throw these two equations out to you and say which one's the inverse and which one's the original, you wouldn't have any way of knowing unless I notated that. So let's say I call the first one, this one, f of x. If that's f of x, then the inverse would be written like this. And so by using function notation, I can easily tell which one was the original and which one was the inverse. Okay? So in this case, the inverse is a function.
So what are they going to ask? Just
Now they're going to ask you to calculate the inverse. Okay? They'll ask you, is the inverse a function? And they'll ask you maybe what's domain and range of the inverse. So what's the domain and the range of my inverse? It's a diagonal line.
So it's script R.
Script R, right? Diagonal lines are always script R. Domain of the inverse is script R. Range of the inverse is script R. Okay? Now if you look at your previous function, the previous problem we did, if I ask you for the domain of the inverse, you would tell me 1, -3, and 5. Domain is equal to 1, -3, and 5. Range is the y values. My range would be 4, 2, 6, and -8. Okay? Everybody okay with that? Okay, example 3. Let's say I've got y is equal to x squared minus 5. So what does that look like? It's a parabola. Parabola that's been shifted how?
Down 5.
Down 5. And I'll even use function notation here. We'll say that's g of x. All right, so I have this function g of x, and I want to find the inverse of g of x. How can I calculate the inverse? Switch. Switch what?
X and Y.
X and y. So this is my y, right? So if I rewrite that with a y, and then switch, I will get x equals y squared minus 5. Add your 5. Now, anytime you incorporate a square root, that means you have to add in a what? If you're going to square root both sides, you better put a plus or minus out here, right? So I put the square root of y squared is y, and the square root of x plus 5 is positive or negative square root x plus 5. Okay, well, what's that? What kind of function is that? That's a square root function, but it has a plus and a minus in front. So a square root that's been shifted 5 left, it looks like.
What's going to have both?
So yeah, it's going to go above the water and below the water. Which means what? Is it a function?
No.
Yeah, the inverse of this one is not a function. Okay, so it fails the vertical line test. My inverse is not a function. So I calculated the inverse. It was not a function. What if they asked me for the domain of the inverse? We can still give the domain.
Point to infinity.
From negative 5 to infinity. Okay, so my domain is negative 5 to infinity. All right, how about my range? I mean, this picture goes forever up and forever down, so it's script R. My range is script R. Does that make sense? All right, now, I want to point something out to you, a shortcut on this, how you can tell if the inverse is a function or not. Like, let's say that's the only question they ask you. They give you this original function, and they say, hey, is the inverse a function, yes or no? How could you quickly tell without having to figure all this stuff out? I mean, look, this originally was a parabola. Now it's a parabola lying on its side. Is a parabola lying on its side ever going to pass the vertical line test? So what you can do is just do a horizontal line test on the original function. So if I have a parabola and I draw a horizontal line through it, it's going to hit 2 points, right? Well, anytime you do the inverse of a parabola, you get a parabola lying on its side. So all you got to do is do a horizontal line test on something to tell if the inverse is a function, okay? So if you think about that sheet that I gave you that had all the graphs on it, some of them would fail automatically the horizontal line test.
I saw that math equation on this.
All right, let's say you have the equation y is equal to negative 3x squared plus 3. And I said to find 4 points on the inverse. Find 4 points on the inverse. Okay, so I could have even said, maybe this is going to be in function notation. Maybe it'll look something like this. H of x is equal to that. And then they'll have something in the answer blank like this. They'll say h of x. They're asking you for 4 points. So a set of 4 points is going to look something like this with 4 points in it, right? So if I want to know 4 points on the inverse, I can just find 4 points on the original function and then flip them around. Rather than actually take x and y and flip them, let's find points on this one and then turn those around. So how can I easily find a point on this parabola? 0, 3. So if I take the point 0, 3 and I switch it around, for the inverse, it'll become 3, 0.
And then you can go
Okay.
down 3/1, so just 0 or 1, 0.
Yeah, but remember it's a parabola and it's actually got a compression on it. So we're going to plug in numbers. That's all right. So let's plug in a 1. If I plug a 1 into this thing, what will I get? 1 squared is?
0. No, you get 0.
Yes. 1 squared is 1. 1 times negative 3 is negative 3, and negative 3 plus 3 is 0. So if I plug in a 1, I get a 0. So if I turn it around, I get 0, 1. Okay, how about a negative 1? What will I get if I plug in negative 1?
Negative 0.
At this time, please release JV football players
96.
going to Anderson County.
If I plug in a negative 1, what's negative 1 times negative 1?
I guess
1.
1, it gives you the same thing. So if you get a, plug in a negative 1 and turn it around, you'll get 0, negative 1.
Okay, then you can also have
So plug in a 2 maybe? 2 would be 4. 4 times negative 3 is negative 12. What's negative 12 plus 3?
9.
So 2, negative 9, turn it around, I get negative 9, 2. So is this inverse a function?
no.
It's not, because the x's repeat themselves, which makes sense because this is a parabola, and anytime you take a parabola and flip it on its side, it's going to fail the vertical line test, right?
Yep.
Okay? So, next example. Let's say we have g of x is equal to x minus 4 over negative 3x plus 5. And you're supposed to find the inverse. How can we find the inverse? Anytime I want to find an inverse, I should do what?
Opposite.
Flip the x's and the y's, right?
Yeah.
This is my y. So if I'm going to switch those, then it becomes my x. And then these become my y's. So once I do that, then I have to solve for x. Or I'm sorry, solve for y. I had to put the wrong thing right there, didn't I?
It's okay.
There we go. So we switched x and y. All right, so I switched x and y, and now I have to solve for y. How am I going to solve this thing for y?
Get it by itself.
Multiply
Get rid of
by
the
3y
fraction.
plus 5.
Yeah, let's get rid of the fraction. So to get rid of the fraction, I need to multiply by negative 3y plus 5. So if I do that, I'm going to have negative 3y plus 5 times x equals y minus 4 over negative 3y plus 5 times negative 3y plus 5. So here's the original, and I'm just multiplying both sides times a negative 3y plus 5.
Did you distribute
Yeah.
x?
I mean, here, those are going to cancel. But on the left side, you're right. I want to distribute that x to both of those. And you're going to have a negative 3xy plus 5x. Does that make sense? Is equal to y minus 4. Okay, now my goal is to solve for y. So I want to get y by itself. I've got two terms that have y's. That's got a y, and so does that. So I need to get them on the same side, right? So I'm going to take this one, and I'm going to move it over here, and I'm going to take this negative 4 and move it out of the way. Okay, so if the negative 4 comes over here, it'll make it a positive 4. And if you move your 3xy over, now my problem looks like that. Okay, well, I'm trying to get y by itself. These both have a y in them, so could I factor a y out of these two? Okay, so factor a y out. If I do that, what will I have left inside that parentheses?
3x.
Okay, well, I'll need a 3x over here, that's right. But what am I going to put here so that I can multiply times y and get this? I can't just leave this blank because that would mean y times 0 equals 0, 1. So I need a 1 there so that when I multiply it back out, it gives me this. Y times 1 is y times 3x is 3xy. Okay, now I've made it easier to get the y by itself. What can I do now to get y by itself? Divide by 1 plus 3x, right? So if I divide by 1 plus 3x, I will get y equals 4 plus 5x divided by 1 plus 3x. And there we go. The y is now by itself. So to write that in function notation, remember my original function was a g. So I would say g, the inverse of g of x, is 4 plus 5x over 1 plus 3x. So this was my original. This is my inverse. Everybody okay with that? Okay, let's do one more. What if you were asked for the domain of this thing?
Script R, 'cause we don't.
Nope, it's not a script R. You got an x in the denominator. Remember, if there's an x in the denominator or an even-numbered root, you got a problem, right?
Yeah.
What would make my denominator turn out to be a 0? Let's see, 1 plus 3x. What makes it 0? You with me, guys? How about a negative 1/3? Actually, they're not the same thing.
What do you think of that?
So x cannot be a negative 1/3. So if it can't be a negative 1/3, what can it be?
1/3.
Negative infinity all the way to negative 1/3, unioned with negative 1/3 all the way to positive infinity. Right? If x can't be negative 1/3 and it can be everything else, then there's what it can be. Right, Jesse?
It's down.
Okay. One more. Now I want to find the inverse. How do I find an inverse?
Change x and y.
Anybody, first of all, what if they said, is this an inverse function? And it was just a yes or no question.
Said no.
How could you avoid working out the whole thing?
You just look at where the x is at.
You look at what type of function it is. What type of function is this?
There's a normal.
What's a 1/3 power?
Oh,
It's a cube.
No, it's a cube root function that's been shifted how?
Right 5.
That's going down 5 and left 1.
Left 1.
Okay, so on a cube root function, if you draw a horizontal line through it, will it ever hit more than 1 point? If you go to the parent function of the cube root, draw a horizontal line through it, will you ever hit more than 1 point?
No.
No. So what's that tell you about the inverse?
It's a function.
The inverse is a function. So if the inverse is a function and the question's just yes or no, you wouldn't have to work out anything.
Just always put yes.
Okay? No, don't always put yes, because sometimes the answer is no. If it's a quadratic, the answer will be no because it wouldn't pass the horizontal line test. But if it's a cube root, that does pass the horizontal line test, right?
Yeah.
Now, so that's just if they ask you for a yes or no question. Now, they may say, hey, you need to actually find the inverse. So if they ask you to find the inverse, what do you need to do?
Find the inverse.
How? Flip the x and the y. Okay, this is the y, so I make it an x. And I make my x a y. And then I solve for y. How can I get the y by itself? How can I get y by itself?
You can bring the 5 over.
Bring the 5 over. So x plus 5 is equal to the cube root of y plus 1. Okay, how can I get y by itself?
Cube it.
Cube both sides. To get rid of a cube root, you need a cube, right?
Yeah.
Okay, so if I cube both sides, now I've got y plus 1 equals x plus 5 cubed. I'm just going to leave it like that.
Okay.
Y is almost by itself.
Bring the 1 over.
Bring the 1 over. I've got x plus 5 cubed minus 1. So now we have a cubic function that's been shifted down 1, left 5.
Left
So the
5.
inverse of a cube root is a cube. Makes sense, right?
Yeah.
The square and the square root are inverses. The cube and the cube root are inverses. It works. Okay, so what would be my domain and range for the inverse?
Script R.
Script R, it's a cubic function, right? They go forever up, forever down, forever left, forever right. There are no even-numbered roots, and there's no x's in the denominator. So your domain and your range are script R.
Oh, that's
All right, everybody okay with that?